and warm welcome, Houston, to Funk
Hi, everyone.
Sweden. Hello, hello, and warm welcome.
Hello from North Carolina, the U.S.
Yeah, warm welcome, Houston, and the stage is yours.
Well, thank you so much. So today I'm going to talk a little bit about what I guess you could say is my own personal journey, but also I think it is a larger, both technical and business case for helping to reconsider the role of functional programming and how it is already in wider use than anyone is thinking if they're only thinking about being inside the software development bubble. So I'm going to go ahead and ask to start with the slide deck, and I'll go ahead and jump into this. There's only a few AI generated images, and I asked it to do this, and I thought it was really cute. So this is my cover shot, and there's a few others that are a lot of fun. But the theme for this is that the spreadsheet, and it started with Excel, of course. The idea is that Excel is the 800-pound gorilla in the room, as it were. But there are open source spreadsheets as well as those provided by other hyperscalers that now are taking a significant share of that. So I just use spreadsheets as a term. But you'll see Excel show up as a term. Most people have that reflex of recoiling when they see a Microsoft thing. Oh, that's not open source. I don't, the idea is that there's a wide pastiche now, and the spreadsheet norm has all kind of flowed from that. So I'll be referring to spreadsheet and Excel more or less interchangeably, and that's not an accident. So this was a surprise to me where the, because somehow my image is missing from that. That's interesting. So in there should be an image of me from 1995 where I'm with Bob Moog standing over the top of a modular synthesizer. My background's in audio and electronics. I also have a minor in computer science from college. And I was always fascinated by the composable nature of the modular synthesizers, and that was kind of my little wink and nod to the fact that I was kind of attracted architecturally to functional programming by this early sympathy that I had from the hardware and analog days. I'm also doing some functional programming all the way down to microcontrollers, which is a reason why that image is there. So back in the late 80s and early 90s, I studied under Bob Moog here at the University of North Carolina at Asheville, and then helped him start his business that eventually became Moog Music, which is now resurgent as an international brand. I've worked in hardware and software projects for 30 years, and before we got started, we got a chance to touch on some of that. None of that's important for this particular talk. And also tangentially, I've been involved with the F# community long enough that I eventually took a role for a time as a member of their the board of trustees for the F# Software Foundation, which is a nonprofit that manages the IP around the F# language itself. So one of the things I wanted to talk about was the need to kind of correct the perspective a little bit whenever we talk about functional programming. And this was a surprise to me. We'll get into that in later slides, but I want to start with kind of like the basic reflex that I think a lot of developers have, which is also the same reflex that I had for many, many years, which is as soon as someone says, I mainly work in Excel, you start to eye roll because you think of all the problems that they might have invited for themselves, think about the difficulty of translating all of the formulas into actual code. And this was back before I was doing a lot of functional programming. So, and particularly if you're working in the data sphere, you encounter this really consistently. And of course, people end up actually developing a level of craft. And later we'll see in some of the slides that can end up coming back to Python. And that's part of like the I guess you could say a negative anticipation of that eventually becoming a reality that you have to deal with. So you'll see this, this conversation where you're trying to smile and kind of look at what they're doing, but at the same time inside your head, you're like, as soon as Excel does what Excel does, which is turning a decimal into a date or a number into something else, it's all going to go sideways and it's going to be falling like a house of cards. And that's a natural, everyone's had to deal with that. It's a natural reaction. And the legitimate issues are those issues that we always list. And these are issues that I've always listed. And that's, of course, the limit for the number of rows per tab, the inability, when they have 16 spreadsheets that are all different versions that they themselves can't keep up with the version that they should be showing you, which is the latest or what have you. The lack of an actual, I guess you could say, objective audit trail. They kind of have they can build their own audit trail if they're very deep Excel users. Of course, the fragile data pipeline or really not having one. And security and access control, where once you email that Excel spreadsheet, it's out into the wild and anybody can do anything with it. And of course, that's changed a little bit over the years, but the idea is like, these are all the general things that happen with an unmanaged artifact like that. And then, of course, the thing I mentioned where my numbers are all dates now. If they end up doing something untoward and they kind of get off the beam, as it were, and Excel can kind of not do a very good job of helping someone back on. So when you give all these reasons to somebody when they say, I use Excel, and say, this is the reason why you shouldn't be doing it, that's when things kind of get quiet and they kind of pull back. And this is a natural reaction. What they want to do is they want to hear somebody express a reflection of their needs, and really what they're hearing is all the things that they're doing wrong. Now, I do that. I did that. And I've gone through some training with a methodology called nonviolent communication. And I've really tried to pivot away from being in that tech nerd perspective and just reflecting my expertise back at them instead of actually hearing the message that they're actually sending. So different people are in different parts of that journey. And I think if you've been involved as a consultant or if you've been a software engineer for a long time, over the time, you eventually develop some of those reflexes to counter that immediate nerd reflex that you have of telling them all the things that are wrong with what they're doing. But the problem is that this can end up creating a perverse cycle that works against you, and that you either don't get the project or you don't get the participation that you want, and the project doesn't have the traction that it wants or that you want for it, and that shadow IT develops out of that. And then, of course, all the other secondary issues around office politics that we all know about. So the problem is in ourselves. And basically what, the idea is to kind of have a little bit of reflection of saying, how do you view what they are doing in Excel as essentially good and essentially useful to them for their business purposes, and really take it from that perspective. Sometimes you put on a pretty face for that, but there's actually a really nice way to frame this for yourself and for ourselves as functional programmers. They can also change the discussion that we often have in why functional programming is not more of the norm. This gets a little bit into a video that was put on by, I've forgotten his name, but the developer of Rock, who did this thing at a closure convention of talking about why isn't functional programming the norm. And I remember sitting there the whole time and both enjoying the video, and he did a very good job of presenting it just on the technical terms. And that how functional programming is really proliferated into other general purpose and multi-purpose languages and ecosystems. But the other thing is this Simon Peyton Jones thing that I will reveal later, is that it already has one. It's just that we don't recognize it because we're so inside of our own mentality of facing inward towards programming languages and not thinking about using technology to solve a problem as a general rule. So we have all these charts that we look at and react to that show this really busy thing. Actually, maybe if I go back here, the bizarre thing to me was looking at this TIOB. This is from November 2025, and Visual Basic is in the middle of this. And that was a weird thing because Visual Basic isn't really actively developed by Microsoft anymore. It's kind of just in maintenance mode. And the reason why is the methodology, the way TIOB looks at this, and the fact that there's a lot of remediation that's going in, and therefore it's popping up in the chart because there's a lot of people either working to modernize what they've got or to get out of it completely and take it into any of several directions like C# and maybe even F# in certain cases. RedMonk tries to do a different methodology. And again, this is that signal that, if you're looking at query volumes and you're only looking at it for languages, there's two things that you're missing. And this actually started with a project that I was doing for myself when I heard the Simon Peyton Jones thing and kind of sidetracked, which is just because you're using a language doesn't mean you're not doing functional. There could be functional ways to use C and C++. There are functions because it's a multi-paradigm language. C# is now aspiring to be more functional because it's borrowing things out of F#. And of course, you have all the things in the Java ecosystem where you have those languages that are primarily functional, such as Scala. And I was a big fan of Groovy, really enjoyed working with that for several years. And and there are functional ways to do things with dynamically typed languages like R and Julia and so forth. So when you just see a language, you don't necessarily know how it's actually being used, but you can, of course, make a safe assumption. I call this a PIPL index, but they are really doing this thing of looking at leading indicators and looking at indicators of what people are trying to learn. So at least it's not a reactive indicator of looking historically of what has been going on over a certain period, within Stack Overflow like they do for RedMonk. But again, it's the same players that are showing up. And we'll see later when you use that same criteria, but then look at other things, you'll see that the chart will change significantly in most cases. So there are some hidden assumptions here, and that these metrics measure a specific population, and I talk about that being inside the beltway of the software engineering community. And the number seems pretty big on its face, that we have 25 to 30 million software engineers in general, maybe more now because of the AI boom, that represent billions of dollars worth of value that's being generated for all the software engineering that's being done. And so all that seems very big. But the question is that the right denominator? And the question is, if you ask yourself the question of, instead of what do software programmers use, and making it software programming and software engineering centric, think about what do professionals do to get their work done with technology, of course, is the implication. Because I guess if you're splitting wood, it's not that much different. But the idea is, if you look at spreadsheets and the way that is used as a technology from a general perspective, you're being much more forgiving than you are within this very specific inside the bubble view of software engineering. Is now you're in the scale of billions of people that are doing things, and they're not all doing software programming inside of Excel. But the general idea is that the scale is so much larger, you can't. It's very difficult to be able to even use the same arguments. So, it comes back to this thing, and of course there's references for whenever there's a statistic there, but it's not referenced. I'm actually going to produce a document that shows where these things come from, because you don't know whether or not it's a hallucinated thing, or the old joke of there's lies and then there's damn lies and then there's statistics. So methodology matters in the same way that we look at Red Monk different than we look at Pipple versus Tyobe. It also matters for referencing these things that come up that might come from Gardner, and they might just be making it up. So, but the idea is that in general, in terms of just pure scale, you've got 50 to 70 Excel users for every software engineer on the planet. And that's just a reframing to say, wow, this really is a bigger world than we're really thinking about. So the term that we used on the West Coast, in both in fintech and in entertainment, is that what we said was Excel is finance OS. It's a very short phrase, and of course, spreadsheets are the operating systems of businesses. A much more generic way of framing that. The basic idea is that these business leaders who rely on this, or the people that they rely on to build this for them, whether they're actuaries or accountants or people that are just in technical roles that actually build Excel spreadsheets, is they then take the Excel spreadsheet and they work with it, and they get to know it, and they become familiar with the process and going through step by step. They can do decomposition inside of Excel that they can't do with someone just gives them a React app necessarily, although I'll be showing an app in a minute that's using solid.js that kind of does the full unpacking, which will be fun. So, there's that cycle that they are always reticent to get engaged in, which is talking to a technology group or an IT group. And then there's this black box period where this group runs off and does a thing. They come back with a thing that then is supposed to represent what they are doing in Excel. And there's what to them looks like no coupling to it whatsoever. And that happens all the time, particularly in data projects or analytics projects. And the basic idea is they have that gap where now they have to go and throw away the investment that they've made in Excel to reinvest in this process that may not look anything like Excel. And sometimes that means that they get there and you end up having some success, but it is a second journey. There's a technical journey of that gap of them, that black box period where someone has to go off and do the work. And then there's that second reacquainting thing after they've already put a significant investment into getting familiar with their decomposition of the way they see things within Excel. That's neither good nor bad. That's just a reality. So, and from their perspective, Excel and even throwing around CSV spreadsheets and then an email of like how things are calculated, that feels lock-in free. And to a certain degree, it's bizarre, but also kind of is lock-in free. You're not married to a specific language, and therefore, eliminating constituencies from being able to have the conversation. The Excel spreadsheet model, or whether you're using numbers or LibreOffice Calc or the Google equivalent, it's all the same visual language. And of course, humans are much more attuned to a visual language because we drew paintings before we actually had written language and so forth. So there is this bridge, though, where the things that they look for that are the positive things in Excel spreadsheets actually do map well to functional programming tenets. And that is not an accident. We'll get there in a moment. Predictable results also kind of maps into that thing of the same inputs, same outputs, referential transparency, the traceable logic and explicit dependencies, which we're going to show later. And then, of course, the phrase of reliable updates is relative to this thing of like they take an action and then they actually see the result of that action, and that helps them gain confidence in what they're doing actually has meaning to them. So they're able to do this cumulative composable building of volume of meaning by having individual places where small things happen, and they make a change that basically builds a dependency graph that they're carrying in their head intuitively. But the mechanics of the spreadsheet itself is actually reinforcing that and providing them an avenue to have greater confidence in what's going on in that view. And as developers, we know that only can go so far, but that it is a legitimate thing. So from our perspective as developers, we can then now have this bridge to talk to them and saying, oh yes, this thing where this cell has this reliable behavior, that's what we call functional purity. And the referential transparency, declarative semantics, and almost like SQL kind of language where they're using a formula that says, I want to express this thing and I want to get a standard deviation of this range of values. And you do STD, STV, or whatever that abbreviation is. They know declaratively what that does, and they select the range for it, and they get a value back. And maybe they did their course in college, but they don't ever have to sit down and hammer out the math by hand anymore. They can just declaratively do it within Excel. And of course, functional programming has that model, and we all know that. And it's one of those magic superpowers that once you get the primitives right, then you can actually end up building something that looks like a higher level DSL that can look like pseudocode, but it actually is executing logic. So these are all things that are the positives of how a spreadsheet can map into the world of functional programming, and it gives you an avenue to have a meaningful discussion with them. But there is a dark side, and we all know about that dark side. And that's usually where our first reflection comes from. Of when someone says we primarily do our work in Excel, you think about all the pratfalls that can happen. And there are real world consequences to this. So I'm giving you some ammunition to make the positive argument. I'm also giving you the ammunition to make the argument of why the dangers lurk and that there are serious pitfalls that are there in Excel that have actually happened to business, that if you either have selection or survivor bias, you don't think about it as often. You can bring these up in conversations as well. So there's the Fidelity Magellan incident, which was a huge, huge issue back in the 90s. And that was back when $2.6 billion was a big deal and people were all talking about it. And it literally was just a change in a minus sign. So it was to a certain degree that this thing of having the control and composability and cell level reactivity is a way to not have hidden state. Because the formula was behind the scenes, it was a form of hidden state and no one saw the mistake and it wasn't caught. So there's a double-edged sword to this thing of having no hidden state within an Excel spreadsheet. The London whale issue, and this is 2012, and kind of in that echo of the big crunch that happened in 2008. And I was working in fintech at the time, that there was this thing that we all knew about inside the Beltway, this huge loss that happened because of a value at risk calculation that went sideways. And it was a transaction that couldn't be unwound, and therefore they had to eat that loss. This was a bit of a kind of, again, it's still in that world of trying to survive that 2008 to 2010 big credit freeze. But there was a mistake that was made inside of Excel where someone hid something, but because it was hidden, it looked like it wasn't actually there. And so whenever the artifact was sent over to someone, and that is that thing about when the email goes out and the artifact goes out, you no longer have control of it. Once you unhide those rows, those things are there, and that led to them being contractually obligated to actually complete the transaction with those rows included in the artifact. So I'm going to circle back to emphasize the bright side, that finance professionals and people that work with Excel in general, even if they're not in finance, backed into and continually back into the advantages of functional programming, even if they don't recognize it. So they didn't read any of the papers. They just needed to get their job done and use this as an experimental tool to build up the knowledge and go, minute by minute and cell by cell and build up into a larger cascade a graph compute that made sense to them for the larger picture that they're painting. So inside of that inner loop of someone working within the Excel by themselves, there's that positive thing of a predictability, a traceability, and that composition of elements to lead to the bigger picture forming. So whether or not they recognized it, that led them into a functional paradigm. And that's something that functional programmers, when you're trying to convince a technical group or a business group to, take a chance on or to adopt these principles intentionally by activating a group to be able to build an application using functional programming, that you can describe the positives of that to them in terms that are very grounded and very real to them. So there's more than just a surface level and visual level of connection in the way that functional programming is involved with spreadsheet architecture. You can see here, of course, we're talking about all the theory and all of the elements that in our world that we really hold dear, that actually maps over into Excel. But that was actually intentionally done by Simon Peyton Jones starting back in 2017. So Excel has already existed since the 90s. Excel, it seems like it is a Microsoft native project, but it's not. It actually started on its own, and it was in the world with Lotus 1, 2, 3, was eventually acquired by Microsoft, and then now has become an institutional centerpiece for the Office suite. So over the years, that's continued to develop, and they wanted to go to the web, and of course, with Office 365, we know where that has all gone. But Simon Peyton Jones was curious. He was in Microsoft research and was interested in actually figuring out a way to do a formal expression of the full calculation engine for Excel, which is written in C, and took no Microsoft dependencies because it was built outside of the Microsoft ecosystem, and re-expressing it within TypeScript because that was being developed at the time, in order to be able to support what eventually became, I guess you'd say, Office for the web, or I forgot what they were calling it back then. And he actually built this calculation engine and expressed it in F# before he then wrote it in TypeScript for calc.ts, and that eventually becomes a link that I provide here at the bottom, and will be part of the links that you can follow. And there are articles from that period where Microsoft Research talks about it. I think it's from 2019, which is after they'd already done all the hard work. So his goal was not only to recreate the calculation engine for Excel proper to a web available version in TypeScript, but he wanted to also add a Lambda and to make it Turing complete. And so that's where you end up seeing let expressions and Lambda showing up. And that was something that kind of leaked over from F#. And I guess you could say OCaml by extension. And so you end up having this thing where we've all seen this, where you have a sum over a range, and you have all these things that you can express whenever you show that formula to someone. Say, hey, this is just functional programming. These are the things that are happening whenever you see this formula in an Excel spreadsheet. Here are other examples, and of course, the Lambda and Reduce is kind of a little bit more late breaking news, and not every calculation engine has this, but in the ones that are more advanced and more complete, you'll see this, and so you can end up having things that actually look like a pseudocoded version of Lambda calculus that ends up actually being that and doing that. And of course, here I talk about the availability of recursion and currying and things that we all talk about and love. But again, you can put it in context of putting it inside of an Excel spreadsheet and say, whenever I say this thing, it's exactly what this spreadsheet is doing. It's just happening in an application. So you have that runway that's available to you to provide things to them that's not just the surface level, but actually the calculation engine underneath is actually doing it the exact way that you do when you do functional programming in a managed application. So what I have here is a couple of screenshots from the application that I built as a sample. And the idea is that the things that look like a web version of Excel really underneath the hood is still just functional programming. This is the reactive cell that, as you see, is described here. It basically goes through and propagates through the graph, and only the affected cells will actually compute. Here's a formula expression that actually it is designed to return another function. So this is like this higher order capability within functional programming that it actually happens in Excel all the time. So again, it's that thing of like giving them an example to say, hey, whenever you see this thing was happening where you're actually taking this function and passing it off to this other thing because you have a reference to it, we're just doing the same thing in here. And anyone that's done advanced formula construction and spreadsheet manipulation within some spreadsheet application, they're going to have some kind of intuitive hook for that so that they can recognize it and see it and build a stronger bridge for them to learn to trust that. So I am going to switch my screen to show my, yeah, thank you. And I'm going to go over here, do this. And now I'm going to go back to hopefully, and is this going to be a problem? Let's get over here and do, can you all see my screen? Hopefully I didn't flash you too bad. I'm actually going to double check. I'm switching between. Can you see what the spreadsheet?
Yes.
Okay. This is blown up as large as I want. This is basically a solid.js application that lives in the browser. It's deployed in Cloudflare and was written in F# and then compiled to JSX through the Fable compiler. So the basic idea is to be able to show, that you have these formulas that pop up, and I apologize for those that have small screens and can't see that, but it will get better here in just a moment. Then when you change these factors that go into the calculation, let's see if I can actually make it a little bit larger. Change these factors in the calculation that it goes through here in the console and actually gives you an output of what was actually done. So it tells you the formula that is being used and considered in the recalculation that's done. So let's do, there we go. That's a little bit more realistic. So this is the kind of thing that you end up seeing inside of Excel all the time. And this is, a garden variety thing. Instead of you having the formula bar at the top, I'm just doing it as a mouse over. So it makes it a little bit of a convenience feature for me. If you don't like the very small type, I apologize for that. Whenever I blew this up to be a little bit larger, the mouse over still doesn't make that type any larger, which is a browser limitation. So, and of course, you can do it for larger calculations as well. This is doing a 30-year amortization and is, if you change this, it goes through and just recalculates the entire thing, and you have everything that happens all the way through. And you can just look and see that that's where the calculation is happening. So all this was built in F#. It's all functionally coherent, and then is compiled through solid.js and then eventually to JavaScript that is running in the browser, completely resident there, but still holds all the tenets of, and the Fable compiler circles, there was an early marketing phrase for that compiler that they used that was called JavaScript you could be proud of. Basically, the idea is that F# is actually constraining the way that the unscripted version of JavaScript is constrained to be type safe, and that the type safety and the design time within F# is ensuring that the JavaScript is also type safe in the way it's generated. So, so we have this experience. It's very much a, I guess you could say, a native web Excel-ish kind of experience. And you also get the benefit of seeing the cascade of how the calculations are being done based on, this is a lot of calculations, so I'm going to go back to this one. That the calculations are showing that how the cascade goes to the dependency graph. And that, for these things where the total return is calculated and the value and the interest earned and everything, that they actually have the right responsibility. And you can see that these cells are not going in the exact same order. This isn't exactly multi-threaded because this is, running in JavaScript, so it's single-threaded, but it does give you that idea of like, oh, there is a place where it's just going to end up doing some kind of, I guess you could say, opportunistic rescheduling of those calculations whenever they come into the queue. And but the dependency order is still being honored for the major arcana of the factors that are in those top cells and then recalculating down through the graph. So this is my example of showing how there is a direct correlation between writing functional programming and getting an Excel spreadsheet outcome. And for folks that are either working in healthcare vertical or finance or any place where people are in the back office are looking to scale up their applications and they principally are working with some kind of spreadsheet model, that having this conversation with them and being able to show them is a way that, as a consultant and a software engineer, that's had a lot of success. And it doesn't necessarily make things happen faster, but it does allow them to have a little bit more of a kind of a trust factor that allows them to understand and grasp what's going on, and therefore give it a little bit more runway. And that over time allows the application to be more successful. So I'm going to switch back to my view of my face here, and then we can go back to the slide deck. Oop, I see Tom. Can we go back to me with the slide deck? Can you all see my face in the slide deck? I'm looking at Tom in my view for some reason. Okay, good. All right. So there is a business case to be made for functional programming, and I'm going to see if I can switch to focus on this. For some reason, I've got what I should have in my main view. I'm seeing Tom in my main view. As great as Tom is, I kind of want to be able to read my slide. I'm not sure why Zoom is doing this. I'm going to see if I can fix it. Give me just a quick second, if you would. There we go. That's a little bit bigger. Okay, so I can read it now. So again, the basic idea is like it's not just a surface level connection. Formulas are functional programs in themselves. So in the part where you can think about Excel sheets or other spreadsheets in the safe zone of the encapsulation of the cell program, you could say that this is as a direct bridge. You also don't want to leave off the fact that there are other things that happen inside of Excel that you don't want, which is a reason why you want to have a managed application for a lot of these programs at larger scale. So the idea is to change the terminology from using all the things that are phrases that you're comfortable with, which is like we use functional programming, referential transposition, monadic transposition, and effect management. And that ends up translating to them as saying, that's something I don't understand, and therefore that's a risk. And we don't want that. What you want to say instead is say, we take the exact same things you do with spreadsheets and then reliably scale them and put them in these mission critical systems in a way that you don't have the negative aspects of what can happen within a spreadsheet context. And the good news is that we can use this to, have a bridge that we can use throughout the process. So what they hear are the familiar concepts, the transparency of having that metaphor that they can continually use. And then that then translates into reduced risk. So, this is that, postulating the question, and if this is for that executive that does have, an imagination that can imagine this thing of a weird thing happening to a cell in a spreadsheet that they didn't expect or see, even though it's still behind the scenes kind of functionally happening, is because someone made a change that they didn't understand or it can't pierce the veil on. So that's one of those things where they can understand sort of what a side effect means and why weird things happen, and having it under a managed application can actually be all of the positives an Excel spreadsheet offers, but none of the negatives. So this gets a little bit more into the model for that. And I'm at 38. I'm doing well on time. And then, of course, the novel framing is you can read the thing. This thing is not really supposed to be a reader deck, but this is a little bit more of a read. But the phrase I always use with them is, we're not trying to take away your favorite calculator. And the idea is like we're trying to provide the calculator that doesn't break when two people touch it at the same time. And this is a phrase that I use, and I mentioned this before the call, as I was talking about doing work for global royalties group at Universal Music, and all of the actuaries and accountants were all doing the Excel spreadsheet shuffle. We've all seen this, and they're dealing with very large record sets and very large numbers, and there was the constant do-si-do meant that you were really using like SharePoint as a version control, which is a disaster of another kind that we don't need to be talking about right now. So the basic idea was to, help them understand the pain that they're feeling, and that you can give them all the benefits without the downsides. So coming back to functional programming for folks with us within inside the beltway within functional programming, and how we can kind of advance this completely, aside from deciding that we're against OOP and making an enemy of things we don't need to be making an enemy of, is that there are things that we do get the benefit of, that people that using spreadsheets get intuitively from the perspective of them making a change and seeing it happen within the scope of where they're expecting it. And that kind of fearless refactoring that you get within the functional model is the kind of thing that over the life of the application ends up being cheaper to maintain, and something that everyone can have a shared vision of. So again, the idea is to give them that comfort that it's not only going to be something that they can understand while this thing is being built in the run up to making it a production application, but also the roadmap ahead is going to be, less bugs and with lower rework and controlled effects, no pun intended, that everyone can understand and manage as they go along, and sharing that context with each other. So in this parallel universe, this is that thing of, like, in the bigger picture, we're going to say, stop saying we use functional programming and start speaking in terms that they understand. And, applying the same principles in your spreadsheets that are reliable to you, and engineer them to build systems that you can trust at scale. And then, of course, there's the selling points that you have of saying that, with our long and telephonic systems, and what really made that digital telephony, and then, of course, a mobile endemic, and was really kind of like the first wave before the internet really was a big deal for broadly scaled digital systems, is that they had this unbelievable uptime metric simply because of the functional design and actors. And I'll save that for another presentation. And then, of course, they can go to a more modern metaphor, which is WhatsApp, which everyone should have some appreciation of, that it's still using Erlang, and it's, serving 2 billion users, but only has 50 engineers. And that goes to that thing of being maintainable and scalable with a relatively small constituency, and with, mental metaphors that everyone can understand, even if they don't trust Facebook, rightfully. So in terms of, like, who else has been doing this adoption, we have this really nice narrative from Jane Street of using a camel for 20 some odd years and developing it and helping to develop it in the open. And of course, they do billions of dollars worth of transactions on it. This isn't a popularity story. This is about criticality story. So functional programmers will never win on popularity unless you get people to buy into the Excel story. But the idea of the thing is, like, this is not about popularity. This is about the criticality, and about the mental model and what matters to the organization. So if the standard charter is a good Haskell story, Bloomberg's use of functional programming. I did a lot of Scala in fintech before I went over into the .NET world. And actually, one of the first things I found in .NET was the ML.NET library. I actually ported the Scala APIs over, which is one of my mental models of, like, oh, wait, you can actually kind of do functional programming within C#. It's kind of multi-paradigm, even though it was terrible at it. So again, a digression. And I say here, several large banks have substantial functional programming code bases. That means there's some really big banks that have really big install bases of F# that I don't have their permission to say, so I'm not going to say. But there's a lot of functional programming, and I see the F# world in particular, that's being used at great depth and at great length of time, and for large amounts of mission critical systems that are behind the scenes. And one of the reasons why you don't hear about it as much is because it's a relatively small constituency, and it's kind of their secret sauce, and they don't want to talk about it necessarily. So, the basic idea is, whenever the cost of failure is high enough, you have an argument that you can make that they can connect to that doesn't have anything to do about popularity in the broader internet ecosystem. So again, we're going to revisit this thing. This is the Tyobe deck, and then you kind of slide over to, now we're going to use the exact same Tyobe methodology to then go look at Excel, and then add that in and see how it lines up with everything else. And you notice how that squishes just everything down. So this becomes that. because just the scope of the influence of Excel, when you look at it from that perspective, is sizable. Again, with the red mark metric and methodology, you do the same thing of looking at searches and understanding within Excel, and you end up seeing largely the same effect. Where Excel, or this is actually all spreadsheets, so I broadened it to not just look for Excel, but look for pages and numbers and whatever the other weird names, LibreOffice Calc, which is what I use. And then, of course, Pipple is the same, is not the same, but it is interesting because this is about what they are looking for, what people are learning. And so this is a little bit different, where you can kind of see that, spreadsheets are down the list. And I think I might have labeled it as Excel here, but it still makes the top 10. So there are people that are still working with Excel and figuring out how functions work and, how to use Excel. And that still is above Ruby. That's pretty broadly based, and people are using it pretty significantly. And yet Excel is still in this list, even when you're looking at it strictly from a function development perspective. So there are, when you broaden the perspective and when you actually are clear on what really matters for the things that you're going to end up having a discussion with someone about, that's a decision maker, functional programming folks actually have a really strong argument that's based in the fundamentals. So this is the thesis restated, and the spreadsheet succeeded not in spite of what they are, but because of it. And the idea is that you're not going to be asking the leadership to trust something that's abstract, and it may still be abstract, but it's an abstraction that they recognize. And this is just a quick chronology of VisiCalc, Lotus 1, 2, 3. I mentioned that kind of in passing before, and this was my own little thing of like, here are these benchmarks, and there's so much that's happened since that time in the world of, I think there's I forgot the open source calc engine that's out there that's in TypeScript. And that was part of what I used to kind of look at for a model for building the calculations that I did in F#. So I spent quite a bit of time looking at an application in my ecosystem that takes TypeScript SDKs and converts it into F#. And so I kind of go back and forth to understand how that works. So the proliferation of those spreadsheet calculation engines are such that it's no longer the lock-in that you get with the Microsoft Excel lock-in, as you have all seen online and everything. So eventually I'm going to be putting up a link that is a web page in my blog that actually has all of the references to all of the different methodologies and everything for TIOB and everything else, as well as some of the Microsoft research references and a few others. And that will be available on my blog, and I'll be sharing that as soon as it's done. I'll be doing it probably after we're done with this session. And I just wanted to take a moment to thank everyone for listening all the way through this and for writing out this all the way to the point that now I'm ready for questions. So thank you very much.
Thank you very much, Houston. Yeah, thank you very much. Was a really good presentation. I never heard anyone coming up with this. Is like the best twist ever. Have you used this type of? I mean, what I want to say is, like, have you used this type of selling point towards someone, towards some kind of key stakeholders?
Absolutely. This is part of my arc. There's a Channel 9 video that was actually the real inspiration for me, that when I watched it, I was just like, functional, it's like Excel is the best functional programming language. What the hell are they talking about? and then I nerded out, watched it. A lot of it went over my head because, of course, they went to monads, and I wasn't really ready for that at the time. And but then of course, I used LINQ extensively within C#, which is very functional because it was developed by the same crew who helped develop Haskell. So they're like, oh yeah, select any as a monad. And I was like, oh, I got it. Thanks. So I hadn't really developed a narrative to get engineering working groups to be able to get analytics people or people that deal with the finance side and with the big data side of their company, because there's that thing of like, there's the operational applications and there's the analytics sphere over here, and they have this little data transform in between it. And of course, I see it as having a confluence between the two all the time, because I'm the person that was usually building the plumbing. And the basic idea is that people were taking this extract out of these operational systems, and they were just building them into Excel to then go and do transforms. And I'm like, you're basically just building a really poorly defined data warehouse. And they're like, you just said poorly defined. And after that, I stopped listening. So the idea of developing this narrative of getting somebody on board with doing things a certain way, and that's just, it's convincing people to do stuff within Scala or within R, or sometimes within C#. And that was doing Spark transforms. I'm like, this isn't that different than what you're doing within Excel. It's just a lot faster. And you're just kind of like, oh, I like faster. So you give them a little bit of congratulations for this as being close to the model that they're using, and then you get a lot more runway. And I just kind of backed into it. And then learning that Simon Peyton Jones actually built the calc.ts after he did Project Yellow using F#. And I was kind of like, oh, that makes sense. So that was a really good thing. So I backed into this, having this narrative and taking this to both in healthcare and finance and people, back office and other industry verticals, getting folks to kind of trust that doing something within a functional programming language, and mine of choice is F#, couple this Excel spreadsheet and it's just a .NET workload, you immediately get a lot more runway and you get a lot more wins that way. And these applications, once you deploy them, they stick around because they just don't need a lot of maintenance.
Cheers, thanks. Next question. I mean, the FlexGrid you showed, have you used that in any kind of production environment, or has anyone used it, or is it more like to show how it works?
No, I just built that for this, but it was my exercise.
Yep.
I'm building 2 frameworks. Yep. I'm that guy. So I'm building a compiler that takes F# and goes through MLIR and then eventually other lowering strata, primarily right now LLVM, to do native compilation. I'm also doing another Fable compilation that doesn't use React as a front end. And it doesn't use .NET as a backend. So there's this very common stack within the F# community called SafeStack, which is Suave as a .NET backend. It uses Azure as the A, F as F#, and then E as Elmish, which of course we're going to be talking about that in a minute. I'm loving this connection to the Elm presentation that we're going into. And I love Elmish, and I see everything in those terms when I'm building this kind of model. And the idea is I want to do something that doesn't use React. And so this Excel spreadsheet in the web was to do solid.js, which uses the signals pattern. And it is sort of without subscriptions. It's really not a subscription API. There's still subscriptions happening behind the scenes, but that's being handled for you in the graph that's built as the solid.js builder kind of decomposes into the reactive graph that runs inside of JavaScript. So having an F# semantic model that can then compile through Fable to JSX that then can deploy in the front end is going to be the top layer. So I don't use React. And of course, we've just gotten bitten by a React bug with React on the server with Cloudflare. And I don't like React for other reasons because for me, it's not actually reactive, and that's another story. And then have the strata within Cloudflare for Cloudflare workers also built in F# and also built and deployed there so that if you have all the nice juiciness there. So I've done a little bit of that. And so I'm kind of used it as an excuse to get familiar with solid.js. It's a very long explanation for a very short answer.
Yeah. But it was a nice FlexGrid, and I think you really showed the what do you call it, like how it fits together, and how it's all functional,
Right, and I plan on, of course, it's public repo. I'm going to be putting it in the links that's in the page that I'll be publishing, so you'll have a chance to be able to kind of pick it apart and look at it. And there is a parser library called xparsec that actually comes from Haskell that I did not use because it was outside of my innovation budget. I'm using xparsec for other stuff. It's just I couldn't work it around this. But the person who built xparsec, an fparsec in F# comes from parsec from Haskell. So by extrapolation, xparsec is actually going back to a more structured, more functional workflow that ends up using operators that look a lot like the Haskell operators. So it's that weird hybrid of being in the Haskell world, and I'm really interested in that. So I'm going to rebuild the parser for that in xparsec so that I'm developing my own chops and keep it available publicly within the library so that folks, and within the modules within the application, so that folks can pull it down, they can compile it, build it, and push it up into Cloudflare if they want and play with it on their own. But it's fully running in Cloudflare as a Cloudflare Pages instance.
Okay. Again, thank you very much, Houston, and thanks for your presentation. We'll put all the links and everything in the show notes so people can see them later. I guess your like presentation is public also, so we'll put all the links and everyone can, you know, review the go through everything.
And I'll publish. There's a ton of footnotes, so I'm going to just do one
Good.
link to a blog post that will have all the footnotes in it. So there'll be one link for you to post.
Grazie. Grazie. Thank you very much.
Thank you so much. I really enjoyed it.
Yeah, we too. Thank you.